We've taken the side off of this 50 kg. We're going to kind of show everybody what happens when we're running this hammer. The valve on the other side for the no-load startup simply opens or closes this valve. So we either vent all of the lower air to the atmosphere through this valve, this hose, and out, or when we close it to the run position, no air exits, and 100% of the bottom air goes to the bottom of the ram to raise the ram. When we want to hammer, we step on the valve, and that moves this from the closed position, which is venting all of the upper air out the same pipe that the lower air is going out of. It's all going out to the atmosphere. As we close this closes this port and opens this port so that at 100% throttle, we have all of the upper air going to force the ram down. All of the lower air goes to pick the ram up as it cycles back and forth. Let's turn this hammer on again, and you can see how the crankshaft works. Somebody want to hit the power? This is just simply a crankshaft mechanism, and it works very much like a piston in an automobile, with the exception it has compression on both the top and bottom.
Want to talk about that timing belt pulley?
Yeah.
This is nice to see now.
These were originally V-belts, and they took quite a little bit of extra power. So in about 2003, we rolled the rim and shrunk on here like you would do a wagon tire to cover the V's, and went to the cogged belt because we could get a smaller diameter pulley and it wouldn't slip on it, and it had enough surface area on this large pulley to slip without cog. And it allowed us to run it on a 5-horse motor, which most of the time they were on a 7.5.
And the oil fender.
And
the fender.
We do get some oil dripping out of this cylinder, and it would get on this belt. And some other brands of hammers have trouble with oil on the belt. So we designed this oil shield, which simply works like a roof and runs the oil off each end where it's of no consequence. It really doesn't make any difference which way this hammer turns. That piston doesn't care whether this is turning clockwise or counterclockwise. I've heard some people say, oh, it needs to turn a certain way, but I can't see that it makes any difference at all. This is a piston that goes in here, different size hammer, but this skirt here acts as a valve. When these holes come above this skirt into the cylinder, it allows it either to exhaust or intake air, as the case may be. At some points in the cycle, there'll be air coming in. Sometimes there'll be air going out. As soon as the piston drops enough that these ports are covered with this skirt, it starts building the compression below here that is transferred through here to raise the ram. When we were trying to make these hammers, we was trying to get them better. We played with plugging these holes, making more of them, making less of them. It seems that the way they come from the factory was just about optimal. Some of the early models had a ring here, a piston ring. It really didn't need to be there. So the late models, I don't think any of them have rings on them.
How about the lubrication for the crank bearing at the top that we talked about this morning?
This is the piston rod that goes through here. The reason that it's bolted together here, should you ever need to change the belt, you can simply take these two bolts out, then you can slip the belt over there. Otherwise, you'd have to disassemble the whole thing. So this, you take this in two here, belt slips on very easily. Get it over your motor, over the wheel, tension it up, put the bolts back in. Some of the early models had a key in it where you couldn't assemble it wrong. Now then, I think they're marked, so you just put the numbers to the numbers. This is an early model that had a needle bearing, has a hole here. The oil that's scraped off of the inside of the cylinder wall by the rings is up in this area and gets into this to lubricate it. Sometimes it's insufficient and this bearing could go bad. So they went to this bronze bushing setup, and this is the piston pin that goes in here. It's hollow here, and it has a hole here, and it comes out on the side of the piston, and that oil tends to scrape into here better and transfers through the hollow pin, through this hole, into the bushing. And it seems to be a better setup. They are constantly working to improve these hammers. I've been associated with them since 2000, and there are many changes, and I think they've all been beneficial. The more you use it, the more people get to using it, the better ideas. It gets feedback, and through the dealership, like Tom, like Helmut, we get that fed back to the factory, and we get some of those things incorporated. The hammer keeps getting better and better and better. Mm-hmm. These are much better hammers than the 2000 models.
How about the two center punch marks on the where they are going to be at the top, open and close? I think it's at the other side. I don't even know if this hammer has them actually.
Well, this valve and this valve are exactly the same valve. There's no difference in the top and bottom valve. It's just one is turned one way and one is turned the other. And so I don't believe the factory's doing it, but I know I always do it.
I do it.
And he sets up these valves and puts reference marks when it's fully open or fully closed, as the case may be, so that you can tell where that's at. And as we get into revalving this hammer, I'll show you the importance of those. I have a little setup that I made that we can show later, so that we can time these valves properly and know where we're at. We have a turnbuckle between them so we can get them adjusted in time.
How about this valve and this and this? What's under here?
Underneath here is, I call it a poppet type valve. It's just a flat metal disc with a spring underneath it, a light spring, has a row of holes around the cast iron housing, and as the piston goes down, it can suck the disc down against the spring pressure and allow air into the top side of the cylinder. As a piston ascends, it creates pressure, and it and the spring push that plate back up against that cast iron housing to seal the air, to let it build pressure to go in here to drive the ram down. So when it's coming down, it sucks the plate away, the holes are open, it gets its intake air. When it starts up, it creates pressure, seals it off, and that air goes into here.
And that other valve there.
And then this is an adjustment to allow you to adjust the hammer to get it to idle properly, and it bypasses a certain amount of this air to the atmosphere. If it were not here, or this air coming through here would cause the hammer to set and strike almost constantly. So you can adjust this spring and a ball and a seat to allow a certain portion of air away so that the hammer will rise to the top and rest there, pulsing there. But that's an adjustment for that. When we revalve this hammer, we're not going to need this anymore, because we're going to balance one valve against the other and be able to adjust that and do basically the same thing that is doing in what I consider to be a simpler way.
Is there a sealing disc in that one too, just like the one in the back? Or not?
No, all that's in here is a round hole, a ball, and a spring. And this rod adjustment adjusts the tension on the spring. And when the pressure exceeds the pressure of the spring, the ball raises off the seat, it allows air to go out. And as soon as the pressure drops, the ball seats again.
How about a few words about the oiler?
Oiler?
The use of the oiler and what's the appropriate adjustment?
It's a very simple oiling system. Hole drilled into the pump cylinder. It has a ball in there that seats so that it can only go one way. As the piston creates vacuum, it sucks air through this adjustment valve. The oil comes in on the cylinders. It's spread throughout the surface, and the air atomizes the oil and puts it into a mist, and then the oil is transferred to the ram through the pressure and the air that's moving in there. It's just a mist of oil that loops that. If you can get a smear of oil on your finger on this ram, you're getting enough oil, because it's the last place. So if we have oil here, you can be satisfied this is oily. I always, when I start up the hammer, first part of the day, I'll open that valve up a couple of turns and step on the treadle and prime this, because a lot of times there'll be an air bubble in here. And I make sure this fills up with oil. Then I shut it down, and my hammer runs on about 1/8 of a turn very well. These valves have been known to open themselves or close themselves, and Mr. Hellenkamp has devised a very simple way to add friction to that, and he takes care of that for you before you ever get the hammer. So he's dealt with that, and I personally think the oil system works fine. Some people complain about it, but the nasal guys, they think they have to have a gear or chain driven pump with positive pistons to oil the hammer. But they oil all of the bearings in the lower end, which is outside this case, and with that system. So they have a little different need. This system's worked fine on my hammer for 10 years with no problem, and a lot of other people's too.
Do you exhaust yours to the outside too?
No, but I don't, because I'm forever taking my hammer somewhere to demo, and I just have to take it all loose. So I leave it set up so that I can just pick it up with a forklift, set it on the trailer, and move it, and it's ready to go when I get there. Moving this to the outside is a great thing. It gets rid of the oil mist and the noise out of your shop. So unless there's questions, that's really about all I have to explain here.
Okay, thank you.
There are stops here on the treadle that you need to adjust for your treadle position and to ensure that your valves are fully opening but not going past open, because it is possible to over-rotate this valve and to go to a smaller hole. So you limit the travel of the treadle with this, but it also has to do with whether you get a efficient opening in your valve.
And the end positions of this should coincide with the 2 center punch marks on the top of the valve that we put on.
That's correct.
Would you push the pedal just to see, for people to see how it works? Yeah. Stop and stop and stop to the bottom.
Of course, then we have the spring for a positive return, so that we don't get in a bind and go on hammering when you let off. This adjustment is easy to get to. There's an opening on the side of the hammer where you can just get right in there and adjust that easily. Door on a hinge, as there's one back there to service the belt. Then there's a cover here and a cover here with louvers for airflow, so that we can get airflow through here to get rid of the heat out of the hammer. Anytime you're compressing air, you're creating heat. There's a hood goes over the top of this, makes it all look really nice.
How about the XY adjustment and the spherical?
Okay. We have a sow block here, if you will. If you use flat dies, you know the important part, one of the most important things is for the edges of the dies to be aligned. So, to do that, I forget exactly when, but I know it took me 5 years to get Tom convinced to do it. We got this XY sow block where you can just tap this key out and move the top half of the sow block to align your die edges. And then, of course, you can take the key that holds your die in, loosen it, and move your die endways to adjust the ends of the valve. If they don't hit flat, there's a little room to adjust it. It's not a lot, but most of the time it's enough. It has a convex surface here and a concave surface here. And by adjusting these 4 bolts, you can rock that in that area to get your footprint of your flat dies to align properly. It gives you a fair range of adjustment. So we've got concave here, convex here. They fit together and allow this thing to tip like this, and that lets you line up your dies. There's 4 bolts that bolt it together. You can loosen bolts and tighten bolts and align your dies. I normally take a piece of paper, put it in there and tap it, and then you get a footprint of where your valve is, where your die is touching and where it is, and you can adjust it accordingly.
The paper goes between the 2 dies.
Yeah, you just put the paper between on the bottom die and give it a tap, and you'll get a print to show you what you got. This is a very handy deal. Some of the older mechanical hammers had this same idea. Bradley, all of their hammers had this. And it made adjusting your dies very simple.
Okay. I think we covered most of the basics.
These are really good hammers. I use mine almost every time I light a fire. And I've got anywhere from 3 to 5 hammers installed in the shop most of the time, but it seems like I'm always going here and using this hammer. Even I've got other hammers to do other jobs, but it's my go-to hammer as a rule. And I'm really kind of a mechanical hammer guy, but I find myself using it more and more.
And you can soup them up.
We're going to try to soup it up. I come from a race car background, and they're never fast enough, so we're going to try to make it better. Stay tuned for follow more